All right, in this video we're going to look at the consumer's expenditure function and get the consumer's compensated and then ordinary demand functions. So here's the setup. Here's the consumer's expenditure function. Price of good X, price of good Y for a given level of utility, U bar. We want to find the consumer's ordinary demand for good X at an income level of $20. And we're going to assume that the price of good X and price of good Y equal $1 each. Step one is to get the compensated demand for good X. We're going to do that by taking the partial derivative of the consumer's expenditure function with respect to the price of good X. So doing that, I bring this 1/2 down in front, so it's 1/2 times 2. That will just cancel. And then we have to subtract 1 from this exponent up here, so that's why I got minus 1/2. And then finally, we got to multiply this result by the partial derivative of what's in parentheses with respect to the price of good X. And that just leaves us with this right here. Simplifying this mess, we get the compensated demand for good X. Step two is to go to the consumer's expenditure function and evaluate it at $20 of income and price of good X and price of good Y at $1 each and solve for that level of utility. We do that, utility equals 100. Step three, we're going to take the compensated demand for good X and we're going to evaluate it at the prices of good X and good Y and that level of utility that we found in the last step. Simplifying, we get 10 units. Step four, the ordinary demand for good X at an income level of $20 given the following prices. The ordinary demand for good X will just equal 10, and this is because of duality. Minimizing expenditure subject to 100 units of utility is equivalent to maximizing utility subject to $20 of income. Okay, I hope you found this video helpful.